Section 14.3, Apportionment Methods. Upon completion of this section, you'll be able to solve apportionment problems using Hamilton's method, Jefferson's method, Webster's method, and Adams' method. The goal of apportionment is to determine a method to allocate the total number of items to be apportioned in a fair manner. The four methods we'll study are Hamilton's method, Jefferson's method, Webster's method, and Adams' method. The standard divisor is obtained when determining apportionment using the following formula. You take the total population and divide by the number of items to be allocated. A large hotel chain needs to apportion 25 new staff members among 3 hotels based on the number of rooms in each hotel as shown in the table below. Determine the standard divisor. So we're going to take the total number of rooms, which is 675, and divide by the number of staff to be allocated. It gives us a standard divisor of 27. The standard quota is determined using this formula, the population for a particular group divided by the standard divisor. Determine the standard quotas for clinics B, C, D, and E of the First Physicians Organization and complete the table below, and we're using 18 as a standard divisor. So in each case, we're going to take the number of items in the clinic, in this case the patients, and divide by the standard divisor. So for clinic B, we take 201 divided by 18 and we get 11.17. The other office standard quotas are found in a similar fashion. So for C, we would take 196 and divide by 18 and we get 10.89, and so forth for the remaining clinics. A large hotel chain wants to apportion 25 new staff members among the 3 hotels based on the number of rooms in each hotel as shown in the table below. In the prior example, we found the standard divisor to be 27. Now we want to find the standard quota for each hotel. So we're going to take Hotel A, we're going to take 306 and divide by 27 and we get 11.33. For Hotel B, we take 214 and divide by 27 and we get 7.93. And for Hotel C, we take 155, divide by 27, we get 5.74. Lower and upper quota. The lower quota is a standard quota rounded down to the nearest integer. The upper quota is a standard quota rounded up to the nearest integer. The first method we're going to study is Hamilton's method. To use Hamilton's method for apportionment, do the following. Calculate the standard divisor for the set of data. Calculate the standard quota for each group. Round down to the nearest integer, that is, find a lower quota. Initially, each group receives its lower quota. Add up those numbers and see if you've allocated all the items. If there's anything left over to be allocated, it goes to the groups with the largest fractional parts until all the items are distributed. So we're going to go back to the First Physicians Organization and distribute 60 doctors to the clinics. So here we had the standard quota, if you notice in the second line of the table, we had calculated before. We're going to round those down to get the lower quotas. When we do that, we notice they only add up to 57, so we've got 3 additional physicians to allocate, and we're going to allocate those to the clinics with the largest fractional portion, which happen to be Clinic A, Clinic C, and Clinic D. So they go, A goes from 13 to 14, C goes from 10 to 11, and D goes from 11 to 12. We don't give them to B and E because their fractional portion is less than those of the other clinics. And the sum of the totals, we just went over this part here. Now we're going to go back to the hotel example. We had our lower quotas here. We're going to round down. So we get 11, 7, 5, and we add those up, we get 23. So we've got to 2 more staff members to allocate, and we're going to allocate those to B and C because they have the largest fractional portions. So B is going to get 8, C is going to get 6, and now we've allocated all 25 staff members. The quota rule says an apportionment for every group under consideration should always be the upper quota or the lower quota. Let's study Jefferson's method now. In Jefferson's method, we actually don't use a standard divisor, we use a modified divisor such that when each group's modified quota is rounded down, the sum of the integers is the exact number of items to be apportioned. We refer to the modified quotas that are rounded down as modified lower quotas. So here's an example. The Republic of Geranium wants to apportion 250 seats in the legislature. Suppose the population is 8.8 million. There are 5 states, and the 250 seats are to be divided among the 5 states according to their respective populations, which are shown here. If you take the 8.8 million and divide by the 250, we get a standard divisor of 35,200. With Jefferson's method, we're going to use a slightly lower modified divisor than the standard divisor because remember, we're going to round down when we finish. So we're going to try to use 35,000 instead of 35,200. So now we're going to get, for state A, the modified lower quota is now going to be 28. So we're taking each population and dividing by 35,000. And here's the standard quota in the second line, which is dividing by the 35,200. We're going to divide by 35,000 instead. And now we're going to round each of those down. We come across, but we notice we've only allocated 249. We've got one less to allocate. So what are we going to do? We're going to have to go and modify that divisor a little bit more, and we're going to go a little bit lower. We're going to try 34,900, and we're going to do the same steps. So now we're going to divide here in the third row. We're going to divide each population by 34,900, round down, and we notice that we actually now come up with allocating the total 250. And we're going to go back to the hotels now, and we're going to try Jefferson's method with a modified divisor of 25.8. So we're going to take each of the number of rooms and divide by 25.8. And then remember, we round down, so we're going to get 11, 8, 6, add them up, and we come up with 25, which is the good allocation. In Webster's method, we use also a modified divisor, and now we're going to round to the nearest integer, and these are called modified rounded quotas rather than modified lower or upper quotas. So we're going to go back to geranium. Now, in this case, let's go back for a second. If we just use the regular standard quota and we round down, or round to the nearest integer rather, we come up with 251. So this first one would round to 29, 35, 142, 23, and 22. We've got too much there. So in order to overcome that, we're going to use a slightly different larger divisor. We're going to use 35,250 as the modified divisor. And we go through the same steps. So the modified quote is here using that modified divisor. And now you remember round to the nearest integer. So here we have 28, 35, 142, 23, 22, and they round to 250. And so we've gotten our allocation now. And now this next method, we're going to, we're going to go through and do Webster's on our hotels. And we're going to use a modified divisor here of 28. So we take the first hotel number of rooms, divide by 28, the second and the third, and remember now we round to the nearest integer. So 11, 8, and 6, and we come up with 25. In Adams' method, we use a modified divisor now and round up to the nearest integer. So we're going to go back to the Republic of Geranium, and now you want to use a modified standard. With the Adams method, the modified quota needs to be slightly smaller than the standard one, so you're going to use a slightly larger divisor. We're going to try 35,400. And that's shown on the table here. These are the standard quotas, and then we're going to use that modified 35,400. And again, we round up, so we have 29, 35, 141, 23, 22, and we've done our allocation of 250 seats. And let's do this method also for the hotel. We're going to use a modified divisor of 29. And remember now we round up, so we have 11, 8, 6, and we've gotten our allocations done. Of the four methods we discussed, Hamilton's uses standard quotas. The others all make use of a modified quota and can all lead to violations of the quota rule. And here's a nice summary of the four methods. Their divisors are listed here, and then also how the apportionment done, and then whether or not they favor large states or small states.